All right, multiple choice for lesson 30 handout. Problem 1. We have a car driving clockwise around a circular racetrack. Tires on the car rotate 10 times every second. What is the direction of the tire's angular velocity vector as the car travels due east? So the important parts of this problem are actually that the car is traveling due east, and we're looking for direction of the angular velocity of the tire here. So if we have our car that is traveling down the road, we are traveling east. If we are looking top down on this car, that means that we have north, south, and west there, also just to give us a little bit more understanding of what directions that we're going. So if the car is traveling east, then if we think about the tires, if we're looking down on them, they're going kind of like this, going down into the page here. So if they are rotating that way, if we curl our fingers in the direction of the tire's motion, our thumb with the right hand rule will point north. So our answer for this one is north due to the right hand rule on that tire. All right, for problem 2, we have torque, angular acceleration vectors for an object always point in the same direction. True, false, or not an information? Well, if we think about this, we have torque is equal to I alpha. That's our equation for torque. So torque is a vector, which means it has magnitude and direction. Well, our direction only comes from our angular acceleration there. It doesn't come from I, so torque and angular acceleration vectors always have to point in the same direction is true. All right, so the net torque and angular velocity vectors for an object always point in the same direction. So this is the torque and angular velocity vectors. So once again, if we think about it, torque, right, is equal to I alpha. Well, so if torque gets its direction from alpha, does alpha always have to be in the direction of, so is this true, is basically what we're asking. Does alpha always have to point in the same direction as omega? That is not true, because if you're speeding up, alpha will point in the same direction. If you are slowing down, alpha actually points in the opposite direction of omega. So alpha is not in the same direction of omega, which means that omega is not in the same direction as torque. So that is a false statement. Number 4. You're standing on skates on a frictionless ice. Someone throws a baseball to you and you catch it. Which scenario makes you spin the fastest? So you have a baseball thrown straight at you. Are you going to spin around? So our 3 options: the ball is thrown straight at your chest, the ball is thrown at your right or left shoulder, the ball is thrown a few feet to your right or left, so that you have to stretch out your hand to actually catch it. So if we think about this, this is a angular momentum problem. So that ball is coming in straight, but is going to make you spin in some capacity. And so there's a collision there, so it's angular momentum. So our angular momentum equation is R crossed with P, or I omega. So we're looking at how fast does it make you spin, right? Which of these is going to make you spin the fastest? So of these, which of them comes into play? Well, P is just mv, so we could rewrite this as R times mv is equal to I omega times, I guess this would be sine of theta in there as well, because it's a cross product. So we want to know what impacts um, omega the most. So if we take a look at our three options, all of those are changing our radius or how far away we're going to catch it. So if we take a look here, if we um, throw the ball and that ball is going to hit us here, that would be r equals 0. However, if we throw it at our right shoulder, maybe it hits us here. So our let's see, this is our shoulder. It's gonna be our chest. So our shoulder is bigger than our chest. Um, and then say our last one, we're gonna throw us a couple feet out. So we're really gonna have to stretch out there. So our a couple feet away is definitely bigger than RS. So if we think about that, the farthest one away makes us spin faster. So that would be C.